NEET Cracker, channel of comprehensive concepts in physics, chemistry, and biology. Welcome to NEET Cracker, the ultimate channel for NEET exam preparation in physics, chemistry, and biology. Our channel is dedicated to providing you with mind maps and concise explanations of all the important concepts covered in the NCERT curriculum. We go beyond the core concepts, delving into the periphery of each topic to ensure you grasp the subject thoroughly. With our detailed videos in English, you'll be equipped with the necessary knowledge to crack the NEET exam with flying colors. 5 keywords: NEET exam preparation, physics concepts, chemistry concepts, biology concepts, NCERT curriculum. In this video, we will guide you through the essential concepts of physics, chemistry, and biology. Our aim is to enhance your understanding and provide the necessary foundation to excel in the NEET exam. We focus on the NCERT curriculum and go beyond to explore the depths of each subject. So, let's dive in and embark on this exciting learning journey together.
Hi guys, welcome back to our channel NEET Cracker. Today we will be learning about the most important and conceptual chapter of physics, that is kinematics, or motion in one dimension. First of all, we will learn about reference frame. Reference frame is a set of coordinate axes with respect to which we measure the position of any particle. Motion. A particle is said to have moved in a certain reference frame if its position vector changes. Now let's learn about displacement. Displacement. The change in position vector is called displacement. Mathematically, displacement is equal to final position minus initial position. Displacement vector is equal to delta of position vector. Delta here means change. Now a question for you. A final coordinate, that is 3, 4, 5, and it has undergone a displacement of s vector is equal to 2i cap minus 15j cap plus k cap. Find its initial coordinates. Therefore, initial position is equal to final position minus displacement. Initial position is equal to 3i cap plus 4j cap plus 5k cap minus 2i cap minus 15j cap plus k cap. Initial position is equal to I cap plus 19j cap plus 4k cap. Now the next question. The minute hand of a clock tower is 1/2 meters or half meter long and time is 12 o'clock. Take y-axis along 12 o'clock position and find displacement of its tip in first 10 minutes. Now let's look upon to the solution of the first question. Therefore, initial position is equal to 1/2 or half j cap. Final position is equal to half of sin 60 degree I cap plus half of cos 60 degree j cap. Final position is equal to half into under root 3/2 I cap plus 1/4 j cap. Therefore, displacement vector is equal to under root 3/4 I cap minus 1/4 j cap is equal to under root 3/4 I cap plus 1/4 j cap minus 1/2 j cap. Now the next question is to find the displacement when the minute hand dislocates or displaces onto the after 20 minutes. Final position vector is equal to minus of half into sin 30 degree j cap plus half of cos 30 degree I cap is equal to minus 1/4 j cap plus under root 3/4 I cap is equal to minus 1 by 4 j cap plus under root 3 by 4 I cap minus 1 by 2 j cap. Therefore, displacement vector after 20 minutes will be minus 3 by 4 j cap plus under root 3 by 4 I cap. Now the third question, that is displacement after 40 minutes. The solution to the third question is final position vector is equal to half of minus sin 60 degree I cap minus half of cos 60 degree k cap is equal to, not k cap, j cap, is equal to minus of half into under root 3 by 2 I cap minus 1 by 4 j cap is equal to minus of under root 3 by 4 I cap minus 1 by 4 j cap minus 1 by 2 j cap. So the displacement vector is equal to minus under root 3 by 4 I cap minus 3 by 4 j cap. Now let's learn about distance. The length of the path in moving from one point to another is called the distance. Question: find distance traveled in the previous question, means in the third question, which is 2 pi by 3 into 1 by 2 is equal to pi by 3 meters. Note: distance is always greater than or equal to the magnitude of displacement. Now let's learn about average velocity. The ratio of displacement during a time interval to the duration of that time interval is known as average velocity for that time interval. Mathematically, average velocity is equal to delta s vector upon delta t is equal to delta of position vector upon delta t. There is a question for all of you, that is seconds hand of a clock is 1 by 2 meters or 0.5 meters long. Find average velocity of the tip in 10 seconds. Therefore, the solution for the first question is initial position vector is equal to 1 by 2 j cap. Final position vector is equal to 1 by 2 sin 60 degree I cap plus half of cos 60 degree j cap is equal to under root 3 by 4 I cap plus 1 by 4 j cap. Therefore, average velocity is equal to delta displacement vector upon delta time vector is equal to under root of 3 by 4 I cap minus 1 by 4 j cap upon 10 is equal to under root 3 by 40 I cap minus 1 by 40 j cap. Now the second question, which is find average velocity of the tip in 15 seconds. The solution to the second question is final position vector is equal to 1 by 2 I cap displacement vector is equal to 1 by 2 I cap minus 1 by 2 j cap. Therefore, average velocity is equal to 1 by 30 I cap minus 1 by 30 j cap. Now, in the third question, we have to find average velocity of the tip in 40 seconds. From the previous question, displacement vector is equal to minus of under root 3 by 4 I cap minus 3 by 4 j cap. Therefore, average velocity is equal to minus of under root 3 by 160 I cap minus 3 upon 160 j cap. Now the next question. A particle travels along a straight line such that its position as a function of time is given by x is equal to function of time is equal to t square, where x is the coordinate of point and t is time in seconds. Find average velocity during time interval. First question, t1 is equal to 2 seconds and t2 is equal to 3 seconds. Therefore, average velocity is equal to 5 by 1 is equal to 5 meters per second. In second question, t1 is equal to 2 seconds and t2 is equal to 2.1 seconds. So here the average velocity is equal to 0.41 upon 0.1 is equal to 4.1 meters per second. Third, t1 is equal to 2 and t2 is equal to 2.01 seconds. Therefore, average velocity is equal to 0.0401 upon 0.01 is equal to 4.01 meters per second. Fourth question, t1 is equal to 2 seconds and t2 is equal to 2.001 seconds. Therefore, average velocity is equal to 0.004001 upon 0.001 is equal to 4.001 meters per second. Fifth question, what do you think will be the answer if we keep on making the interval arbitrarily small? So we will get the instantaneous velocity is equal to average velocity is equal to 4 meters per second. Now we will learn about of instantaneous velocity. The average velocity for an infinitely small decimal interval of time in the vicinity of a given instant of time is called instantaneous velocity at that time. Thus, if ds be a small displacement in a small time interval dt, then the instantaneous velocity at that instant is given by v instantaneous is equal to d s vector upon dt. Question: the displacement of a particle is given by s is equal to 3t square plus 2. Find its velocity at time is equal to 3 seconds. Therefore, v is equal to ds by dt is equal to 6t is equal to 6 into 3 is equal to 18 meters per second. Note, by default it is assumed that at time is equal to 0, displacement is equal to 0. Question. The velocity of a particle is given by v is equal to 2 cos t. Find displacement. We know v is equal to ds by dt. Therefore, integration of v dot dt is equal to integration of ds. We get integration of 2 cos t dot dt is equal to displacement. Therefore, displacement is equal to 2 sin t. Now, we will learn about average acceleration. The ratio of change in velocity in an interval of time to the duration of that interval is called average acceleration. Mathematically, if delta v vector be change in velocity in a time interval delta t, we get average acceleration vector is equal to change in velocity vector upon change in time. Note that for any trajectory, the average velocity is along the chord of the trajectory and the instantaneous velocity is along the tangent. Question: at which point is the average velocity in the same direction as the instantaneous velocity? At this point in the xt graph, the average velocity and the instantaneous velocity are in the same direction. Now we will learn about average speed. The ratio of length of the path covered in a time interval to duration of that time interval is called average speed. During that time interval, mathematically, average speed is equal to change in distance or change in path length upon change in time. Note, by the definition, it is clear that the magnitude of average velocity is always less than or equal to the average speed. Now let's learn about instantaneous speed. Let dl be the small distance covered by the particle in a small time interval dt, then instantaneous speed is given by v is equal to dl by dt. Note, when the time interval becomes very small, in the limit the chord length approaches the arc length, that is dl is equal to ds. Thus the instantaneous speed is same as the magnitude of instantaneous velocity. Now we will learn about instantaneous acceleration. The average acceleration for an infinite decimal interval of time is called the instantaneous acceleration. Mathematically, instantaneous acceleration vector is equal to limit where delta t corresponds to 0 into delta v vector upon delta t vector, or instantaneous acceleration vector is equal to dv vector upon dt. In case of motion along a straight line, we generally omit the vector sign and write acceleration instantaneous or instantaneous acceleration is equal to change is equal to dv vector upon dt. Differential equations governing motion along a straight line. V is equal to ds by dt, A is equal to dv by dt, A is equal to v dot dv by ds. If a particle is moving along straight line, say x-axis, then its displacement at a general time is given by v is equal to dx by dt. Using the basic differential equations, prove the basic equations of the motion along the straight line with uniform acceleration. First, v is equal to u plus at. Second, x is equal to ut plus half at square. Third, v square minus u square is equal to 2as. Fourth, x is equal to x naught plus ut plus half of at square. V is equal to dx by dt. So, by shifting dt towards this side, we get integration of u plus at dot dt from 0 to t is equal to integration of dx from x naught to x. We get ut plus half of at square limits 0 to t is equal to x minus x naught. Therefore, x is equal to x naught plus ut plus half of at square. General motion with uniform acceleration. Displacement vector is equal to u vector dot t plus half of a vector dot t square. V vector is equal to u vector plus a vector dot t. V square minus u square is equal to 2as. V vector minus u vector dot u vector is equal to 2a vector dot s vector. R vector is equal to r naught vector plus u vector dot t plus half of a vector dot t square. Displacement in nth second. Displacement in n seconds is equal to u vector dot n plus half of a vector dot n square. Displacement in n minus 1 seconds is equal to u vector into n minus 1 plus half of a vector dot n minus 1 whole square. Displacement in the nth second is equal to u vector plus half of a vector dot 2n minus 1. Linear motion under gravity. First equation, s vector is equal to u vector dot t minus of half of gt square. V vector is equal to u vector minus gt. V vector square is equal to u vector square minus of 2gh. Now let's take a question. A ball is projected vertically upwards with speed u. Find its maximum height, time to reach maximum height, and speed at half of the maximum height. First, the solution for the first question is maximum height is equal to u square by 2g. The time to reach the maximum height is equal to u by g, and speed at half of the maximum height is equal to v is equal to under root of u square minus u square by 2 is equal to u by under root 2. It is the speed at half of maximum height. Now the next question. A ball is dropped from a balloon going up at speed u. When it is at a height h, how long will the ball take to reach the ground? So minus h is equal to ut minus half of gt square. Gt square minus 2ut minus 2h is equal to 0. From here we get time is equal to u plus minus under root of u square plus 2g upon g. Drops are falling at regular interval from a roof as shown in the figure. Find the ratio of L1 is to L2 is to L3 when another drop was just going to fall. This is the figure or the exemplar figure for this question. S1 is equal to minus of half gt square. S2 is equal to minus of half g into 4t square. S3 is equal to minus of half g into 9t square. L1 is equal to minus of half into gt square. L2 is equal to minus of half into g into 3t square. L3 is equal to minus of half into g into 5t square. Therefore, L1 is to L2 is to L3 is equal to 1 is to 3 is to 5. Now we jump upon to the next question, which is a ball is dropped from an unknown height. It takes t0 seconds to cover the last h meters of its fall. Find the height from which it was dropped. t0 is equal to 0.2 seconds and h is equal to 6 meters. V square is equal to 2gh. V is equal to under root of 2gh. Minus h is equal to under root of 2gh t0 minus half of g t0 square. Minus 6 is equal to under root of 20h into 2 by 10 minus 1 by 2 into 10 into 2 by 10 into 2 by 10. Minus of 60 by 2 is equal to under root of 20h minus 1. Minus of 30 plus 1 is equal to under root of 20h. H is equal to 29 into 29 upon 20 is equal to 42.05. Therefore, h plus small h is equal to 48.05 meters. A ferry boat, after shutting its engine, moves according to the velocity v is equal to v0 t1 square upon t square. How much will be the total distance travelled by the boat? T1 is the time at which engine is shut. Therefore, integration of ds from 0 to s is equal to integration of v0 t1 square upon t square dot dt from 4 to infinity. Therefore, s is equal to v0 t1 square into minus 1 by t ranging from t1 to infinity. S is equal to v0 t1 square into minus 1 by infinity plus 1 by t1. S is equal to v0 into t1. Now let's move on to the next question. The velocity of a particle is given by v is equal to a e power ks, where a and k are constants and s is the displacement. How does acceleration depend on displacement? A vector is equal to dv by ds dot v. A is equal to a into e power ks into k into a into e power ks. A vector is equal to a square into e power 2ks dot k. In the previous problem, find its displacement as a function of time. V is equal to a into e power ks. ds by dt is equal to a into e power ks. Integration of ds upon e power ks from 0 to s is equal to integration of a dot dt from 0 to t. Integration of e power minus ks dot ds from 0 to s is equal to a outside the integral into integration of dt from 0 to t. E power minus ks upon minus k ranging from 0 to s is equal to at. E power minus ks minus 1 is equal to minus k at. E power minus ks is equal to 1 minus k a t is equal to log e log to the base log 1 minus k dot a dot t to the base e is equal to minus of ks. Therefore, displacement is equal to ln 1 minus k dot a dot t upon minus k. In the previous problem, what is the acceleration as a function of time? Acceleration is equal to a square dot k dot e power 2ks. A or acceleration is equal to a square k into e power 2 into k. S is equal to ln of 1 minus k dot a dot t upon minus k. From here, k and k gets cancelled and a vector is equal to a square dot k dot e power ln into 1 minus k dot a dot t whole power minus 2. A vector is equal to a square into k upon 1 minus k dot a dot t whole square. Or an optional method for this same kind of problem is s is equal to ln of 1 minus k dot a dot t upon minus k. V is equal to ds by dt is equal to 1 minus 1 upon k into 1 upon 1 minus k dot a dot t into minus ka. A vector is equal to dv upon dt is equal to a into 1 minus k dot a dot d dot t into 0 minus of minus k dot a upon 1 minus k dot a dot t whole square. Therefore, from here we get a vector is equal to a square dot k upon 1 minus k dot a dot t whole square. V is equal to b into under root of kx. Find acceleration as a function of displacement. A vector is equal to v dot dv by dx. A vector is equal to b into under root of k upon 2 into k dot x power 1 minus 1 by 2 into b into under root of kx. A vector is equal to b square into k upon 2. Now we look upon to the next question, which is velocity of a particle is given by v is equal to 7t square minus 5. Find displacement as a function of acceleration. V is equal to ds by dt is equal to 7t square minus 5. Therefore, integration of ds from 0 to s is equal to integration of 7t square minus 5 dot dt from 0 to t. S is equal to 7t cube upon 3 minus 5t. A vector is equal to dv upon dt is equal to 14 into t. Therefore, we get t is equal to a upon 14. So, s is equal to 7 by 3 into a cube upon 14 cube minus 5 into a by 14. Now, we look upon to the next question, which is acceleration of a particle varies as a is equal to minus of k into under root of v. At the initial moment, the velocity of a particle is v naught. How much distance will it cover before stopping and how much time will it take to cover that distance? We know acceleration is equal to v dot dv by ds. Therefore, integration of ds from 0 to s is equal to integration of under root v upon minus k into under root of v dot dv from v naught to 0. S is equal to minus of 1 by k into v power 3 by 2 upon 3 ranging from v naught to 0. Final displacement or final position is equal to minus of 1 by k into minus of 2 by 3 v naught power 3 by 2. Therefore, final position is equal to 2 into under root v naught cube upon 3k. Now we jump to the next point of this question, that is a is equal to dv by dt. Integrating dt on the left hand side from 0 to t equates integration of 1 by a dot dv from v naught to 0. T is equal to integration of minus of 1 by k under root v dot dv from v naught to 0. T is equal to minus of 1 by k under root v upon 2 ranging from v naught to 0. T is equal to 2 into under root of v naught upon k. Now we look upon to the next topic, that is area of a triangle. The area of a triangle according to the vector form is equal to half of p vector cross q vector. Now let's learn about the graphs for one-dimensional motion. Classification of sections. Based on the first and the second derivative, the sections of a graph can be divided into one of the 7 categories. The first, this type of graph, it is rising with upward curvature. Here dx by dt is greater than 0, which is the slope, and d square x by dt square is greater than 0, which is the curvature. In second graph, which is like this, it is rising with downward curvature, where we get to see that dx by dt is greater than 0 and d square x by dt square is less than 0. Now we look upon to the third type of graph, which looks like this. It is falling with upward curvature. Dx by dt is less than 0 and d square x by dt square is greater than 0. Now the fourth type of graph, which resembles like this type. It is falling with downward curvature. Dx by dt is less than 0 and d square x by dt square is less than 0. Now we will look upon to these types of graphs. In this graph, it is rising with no curvature. Therefore, dx by dt is greater than 0. D square x by dt square is equal to 0. In this type of graph, it is falling with no curvature. Therefore, dx by dt is less than 0 and d square x by dt square is equal to 0. In this type of graph, it is constant with no rise or fall. Therefore, dx by dt is equal to 0 and d square x by dt square is also equals to 0. Now we look upon to a question that is shown in a graphical pattern. For the shown position versus time graph, identify the sections where first velocity is positive. From this graph, we can figure out that from O to B, excluding B, the velocity is positive. From D to F, excluding D and F, the velocity is positive. And from H to J, excluding H and J, the velocity it is positive. Second question, find where the velocity is negative. So from this graph, from B to D, excluding B and D points, the velocity is negative. From F to H, excluding F and H points, the velocity is negative. And from J to K, excluding the J and K points, the velocity is negative. Find where the velocity is 0. The points B, D, F, H and J are the points where the velocity is 0. Find the points where the acceleration is positive. From A to C, the acceleration is positive. From O to A, the acceleration is positive. From C to E, the acceleration is positive. And from G to I, the acceleration is positive. Find where the acceleration is negative. This is the fifth question. From A to C, the acceleration is negative. From E to G, the acceleration is negative, and from I to K, the acceleration is negative. As you can see the solutions of this question here. Now, drawing the VT graph from the ST graph. For the shown XT graph, draw the corresponding VT graph. So, this is the XT graph and this is the VT graph. From here to here, in the XT graph, we will plot this type of line in the VT graph. If this type of line in the XT graph corresponds to this type of line in the VT graph, this type of line in the XT graph corresponds to this type of line in the VT graph, and this type of line in the XT graph corresponds to this type of line in the VT graph. Now, in this question, we have to draw a VT graph from the XT graph. So, this line corresponds to this line in the VT graph. This line in the XT graph corresponds to this line in the VT graph. This line in the XT graph corresponds to this line in the VT graph. And this line in the XT graph corresponds to this line in the VT graph. Now the next question. For the shown VT graph, draw the corresponding XT graph if the initial position is x. So this is the VT graph given. For this line in the VT graph, this line is possible in the XT graph. For this line in the VT graph, this line is possible in the XT graph. For this line in the VT graph, this line is possible in the XT graph, and for this line in the VT graph, this line is possible in the XT graph. Now the next question. If this is the VT graph given, we have to draw an XT graph. So this will be the XT graph for the given previous VT graph. Follow the same method as I have taught you. Now next, drawing the VT graph from the AT graph. AT to VT is analogous to VT to XT graph due to the analogous differential equation, that is A is equal to dV by dt and V is equal to dx by dt. For the shown AT graph, draw VT graph. This is the AT graph given. This line in the AT graph corresponds to this line in the VT graph. This line in the AT graph corresponds to this curve in the VT graph, and this line in the AT graph corresponds to this curve in the VT graph. Now the next question. Here we have been given an AT graph which we have to convert into a VT graph. So this line corresponds to this type of line in the VT graph. This line in the AT graph corresponds to this line in the VT graph. This line in the AT graph corresponds to this line in the VT graph. This line in the AT graph corresponds to this line in the VT graph, and this line in the AT graph corresponds to this line in the VT graph. Now, drawing speed time graph or VT graph. Question. The VT graph has to be converted into a speed time graph. For this line in the VT graph, which corresponds to this line in the ST graph, this line in the VT graph corresponds to this line in the ST graph. This line in the VT graph corresponds to this line in the ST graph, and this line in the VT graph corresponds to this line in the ST graph. Drawing LT graph from speed time graph. Draw LT graph from the previous VT graph, that is this graph. So this line in the VT graph corresponds to this line in the LT graph. This line in the VT graph corresponds to this line in the LT graph. This line in the VT graph corresponds to this line in the LT graph, and this line in the VT graph corresponds to this line in the LT graph. Now we will learn about the physical meaning of areas under various graphs. Area under the VT graph represents the change in position or displacement. V is equal to dx by dt. Therefore, displacement is equal to final position minus initial position is equal to integration of v dot dt from 0 to t. Note that area above the x-axis is taken as positive and below the x-axis is taken as negative. Area under the AT graph represents the change in velocity. dv by dt is equal to a. Therefore, v minus u is equal to a dot dt from 0 to t. Note, the area below the t-axis or the x-axis is taken as negative. Third point, area under the speed time graph represents the distance travelled. dl by dt is equal to L is equal to integration of speed dot dt from 0 to t. Area under the AS graph represents the change in kinetic energy per unit mass. A is equal to dv by vdv by ds. So v square by 2 minus u square by 2 is equal to integration of a dot ds from 0 to s. Now there are questions for all of you. In this graph, we have to find distance, displacement and acceleration. So the displacement is 0, distance is 2 meters and acceleration is minus 2 meters per second. We have to find the acceleration in this graph. So acceleration is equal to v dot dv by ds. A is equal to 5 by under root 3 into 1 by under root 3 is equal to 5 by 3 meters per second. Thank you friends for watching this video. Please share, subscribe and hit the notification bell for further notifications. Thank you.
Thank you for joining us today on Meet Cracker. We hope you found this introduction to our channel and mind maps informative and exciting. Don't forget to subscribe to our channel to stay updated with all our latest mind maps and NEET exam tips. Remember, NEET Cracker is here to guide you towards success in cracking the NEET exam. Visual display of subscription button and social media hand. Keep studying, stay motivated, and best of luck on your NEET journey. See you in the next video.